Now we'll take a trained model beyond experiments and turn it into a service people can actually use. We'll wrap it with an API, package it in Docker, run it on Kubernetes, and connect that workflow to the cloud. We've built the foundation: what MLOps is, why DevOps matters, and how the ML lifecycle fits together. We also trained a simple model and tracked its metrics, artifacts, and versions. In this section, we move from experiment to product by packaging that model behind an API that applications can call. A trained model begins as an artifact, a file or bundle produced by training. On its own, it cannot serve users. Packaging adds the code that loads the model, validates inputs, runs predictions, and formats responses. Deployment then places that serving application into managed infrastructure with networking, scaling, monitoring, and security. The key idea is repeatability. The same model version should behave consistently in testing, staging, and production. Serving turns a trained model into something other software can use. A user, app, or service sends data to an API built with a framework like FastAPI or Flask. The service checks the request, prepares the inputs, loads or accesses the model, runs inference, and returns a JSON prediction. Supporting endpoints such as health checks confirm the service is running, while metadata can describe the model version or expected input format. A prediction endpoint is more than a URL wrapped around a model. It is a contract. The request should define every required feature, its type, and its acceptable range, usually in JSON. The response should be just as predictable: the prediction, confidence, or probability, and often the model version. Add a lightweight health check, so orchestration tools know the service is alive. And validate inputs before inference, so bad data fails fast instead of producing misleading results. Flask and FastAPI both let you wrap a trained model in an HTTP endpoint, load the artifact when the app starts, accept a request, and return a prediction. Flask works well when you want something minimal, familiar, and easy to customize. FastAPI adds stronger defaults, especially type-based validation and automatic OpenAPI documentation. For production, either framework should run inside a proper server, container, or platform that handles scaling and reliability. Docker acts like a standardized shipping container for software. You package the model service with its code, Python libraries, runtime, configuration, and often the model file itself. That package is the image. When you start it, it becomes a running container. Because everything travels together, the service behaves much more consistently on a laptop, in testing, in Kubernetes, or in the cloud, reducing the classic "it works on my machine" problem. A Docker file is the recipe for rebuilding your model API anywhere. Start from a small Python base image, such as Python 3.11 Slim, so the runtime is predictable. Then install packages from requirements. .text before copying the app code and model artifacts. That ordering helps Docker cache dependencies when only the code changes. Finally, expose the service port and start Uvicorn on 0.0.0.0, so traffic from outside the container can reach FastAPI. Before deployment, prove the image works locally. Build it with Docker built model API v1. Then run it and expose the API port with Docker run p8000. 8000 model API v1. Once it starts, call health and expect a 200 response. Finally, send a representative request to predict. This confirms the model loads, dependencies resolve, routes respond, and inference returns the expected shape. Kubernetes shifts model serving from start this container to keep this service in the desired state. A pod is the smallest unit, typically wrapping one model serving container. A deployment creates and manages multiple pod replicas, replaces failed ones, and rolls out updates safely. A service gives clients one stable address, even as pods come and go. Together, these pieces provide scaling, reliability, and controlled releases for production model APIs. In practice, Kubernetes deployment starts with a YAML manifest. It declares the model API image, the replica count, and the port the container listens on, such as 8000. The deployment keeps the requested pods running and replaces them if they fail. A service provides a stable endpoint and routes traffic only to matching healthy pods. From there, access can stay internal or be exposed through a load balancer, ingress, or managed gateway for users and applications. Once your model API runs in Kubernetes, operations become safer. If traffic rises, Kubernetes can add replicas so requests are spread across several pods. When you deploy a new model version, it can replace pods gradually, avoiding a full outage. Health probes tell Kubernetes which pods are ready and which should be restarted. And if the release misbehaves, rollback lets you quickly return to the last working version. Across cloud platforms, the important pattern is portability. The model service stays packaged as a container, while each cloud provides managed services around it. AWS pairs EKS with ECR, load balancing, and CloudWatch. Azure maps that to AKS, ACR, load balancer, and Azure Monitor. GCP uses GKE, artifact registry, cloud load balancing, and cloud monitoring. The trade-off is less infrastructure work, but more provider-specific configuration. Before you call a model production ready, make sure it can survive the basics. Version the model artifact, dependency set, and API contract, so every release is reproducible. Test container startup, health checks, and prediction responses before deployment. Set resource limits, required environment variables, and security defaults. Finally, ensure logs and metrics are emitted from day one. If something fails, you want evidence, not guesswork. You've now connected model development to production deployment. A trained model becomes useful when it is served through an API, packaged consistently with Docker, and operated on Kubernetes or cloud infrastructure. Next, we'll complete the MLOps loop with CI/CD, monitoring, and retraining, so deployments stay reliable over time.